Hello everyone. So today we are planning to see streaming. Now streaming can be Spark streaming uh, as well as streaming through other tools. Now when we are coming to streaming, right, which is Spark streaming, pure Spark streaming, that is there is a concept called D streams. And now after this 2.4 there is a concept called structured streaming. Now what is structured streaming and why we use that? Generally nowadays for small streaming activities we use that structured streaming. Structured streaming is something like, you can think like a table, right? An Excel sheet, say a row is there, or a table. What happens when you are inserting a row, right? One row, two row, three row, like that, and it is infinitely expandable. It can be extended till infinity. You can insert 1000 row, 2000, 1 lakh, 2 lakh, 5 lakh, like that. So that is the help of structured streaming. What structured streaming does is it creates kind of a tabular data frame which is extendable till infinity, like you can go on adding. Now today our case which we will be seeing in structured streaming is we will be creating some dummy record, and then we will be reading and seeing how it works in the Spark. See, there are other tools also like Kafka and Flink and all that, but first we will see Spark, pure Spark, how you can do a streaming in pure Spark. Now the thing might be that why we need the streaming, right? What is streaming at the end of the day? Streaming is nothing but when you go, say when you are seeing that Sensex, right, or when you go and see the flights, right, this flight is coming this time or something like that, those messages, right, those are what happens. That is like a real time it is updating that, okay, within minutes or seconds, that say in the Sensex, right, in the market, what happens there, 1 rupee is increased or 1 rupee goes down, it happens per second. And if suppose that stops, right, it's a big problem. So that data is nothing but a streaming data. It is streaming each second, it is streaming, it is coming, it is kind of live data, right? So that is where the streaming detail comes. Now we first, in today we will see the Spark streaming and how we will also do a small use case of a streaming and see basic Spark streaming. And then next day we will see Kafka is also a tool. See, Spark, what is that? Spark is a in-memory computation. So it will read and it will do whatever the activities is. Now for streaming, right, see, there can be different kind of architectures, right? One architecture can be, suppose while you are streaming, right, you are streaming from a file location. There is a file location, suppose there is a Sensex record, okay, and the data gets updated each minute, each second, one file comes, and once that file gets increased, right, or the new data comes, it gets increased, appended. So that can be one way. Another can be which happens using the port. So through a port, right, the streaming data comes. That also can happen. Even it can be in a database. Whenever there is an insert, there is the queuing system and the data will get updated in some other place. So that also can happen. So there can be different kind of architectures which you can make for streaming. Today we will see two things. One is we will see this file how streaming we can do, and second thing we will see is that another thing we will see is we will use a Twitter thing to see how Twitter we can stream with the basic. It's not about Spark, the Twitter one, because I just want to show you first the initial glimpse of how you can do a Twitter streaming. Then we will do an analysis and we will store in the Hive and we will do many things. We will try to see the details. But the main thing is, first initially you have to get the data. But we will do today, with Python, pure Python, and that Python we can easily extend to the to streams. That also we will see that, and how we can make it into Kafka and all. That we will see in the next video. And also we have plans to go into machine learning because that's a huge thing. So it will need some time to grasp all the theories of it, because there is a huge theory behind it. If I show a simple code of, say, a linear regression or a logistic regression and tell this is happening here, that will not connect the dots. That's what I feel. So that is why I will not go with that. I will go by first going through the theory. That also I will do from next time. So now let's see our whatever we will be showcasing today, the streaming part, right? So first thing here, you can see, like initially we are going and we are creating a session and all that stuff. Post that, in this line, right, we are creating a data frame. This data frame, we are purposefully putting a data. What is the data? The data is like one ID is there, suppose the user ID, and that guy does Facebook or Twitter or Insta or whatever. And along with that, right, see the schema also we are defining here. So this is the user ID, this is the app he is using, like Insta or FB or Twitter or whatever, and time in seconds he spends, and what is his age, so that we can do an analysis, right? And on the fly we will create a CSV folder and store the data in that, and post that data, right? See, this is comma separator. I will show you the data once it is created. Then we are creating a temp view. This is totally in data frames now we are going into. So then it's a simple thing. We are doing a select, which we do for each app. We are finding the count. Now this seems very simple, right? There is nothing inside that. We are just going, we are just reading streams, although you can see the difference here. It is a read stream. Previously we never used this. So that read stream only we are using, and we are just doing a write. And this write, right, is having different ways. Like when we are doing a write, the write can be this write output mode, right? It is a complete, but it can also be an append. If you go to the definition also, right, it will say it can be append, it can be an update, it can be an complete. So complete means that for each of the, say, milliseconds, right, or each of the even that also we can define here. The thing is that when we are reading the data, right, the data when it is coming, that can come in two ways. One is it can be event driven. So whenever a file is changed, you go and do an update, or the data gets changed and it reflects. Or else it can be time driven, like each 2 seconds you go and you check what is the data, like it is kind of polling, right? So that also can be done. For that we have to do here dot trigger, and you can put whatever time you want. So from here you can do that after this. Okay, so but here what we are doing, we are printing it to a console. You can do in a memory also here, and you can also, there are other formats. I believe here it will show. No, it's not showing. But what you can do is you can do memory also. So memory, if you are doing, it will not show in your console. And whenever you are aggregating, right, like I am aggregating here, always do a complete, because see, when you are appending the data, right, append means what? Append means data is getting incremented one by one, right? So that cannot aggregate, because unless you have the whole picture, right, for that millisecond, say, for that instance of time or that event, you cannot have that, right? So that is why with when you are doing an aggregation, you have to always use a complete. Otherwise you can do an update or append. So append means it will just go and increase one rows, and update means it will check and it will update the row. That is for it. This is the console. So now what we will do, we will run it. So before running, I will just show you the structure of my this thing. See here, you can see this is the structure, right? Now once I run it, right, see what happens. See, now once we run it, right, a folder will appear here. Once again, it is taking a little time because it's creating all that. Yeah, so now see that schema is also printed here, that schema which we have defined above. And now one second, okay, it is it is to be created here only. One sec, somehow not reflecting in the front end, means in this UI, because I have deleted and probably created multiple times, so it might not be visible, but ideally it should be. Let's just do a close and okay, resources, it won't be, it should be here, but it is not here. Okay, anyways, so we can see here, right, that it is telling there's one Insta, one FB, one Twitter, because in the data, right, why it is telling, because we have defined 1 2 3 records, right? Now say another user comes, right, this user, we come to know that he is also using some other. I will just show you the data probably. See, this is the folder actually which gets created, and ideally what will happen is it will come. See, now it has come actually. Yeah, once I opened it, it has come. So it would appear like this here, it has come. So now see, these are the files. Once there will be two kind of files, one will be the CRC ones and one will be the CSV ones. You have to open the CSV ones. See, few of them will be blank, as we have discussed previously, right? It will depend upon the partitions. See, now we know this file contains this FB, right? And see, this polling, if you see here, right, it is not stopped. Our program is running. Why it is running? Because this, if you see, what we are doing at the end is we are awaiting the termination. So we are not terminating it. So it is like polling the folder. It has created the folder and it is polling the folder. Now what we will do is we will open a file, we'll check the data, and the second thing we will do is yeah, so this is having a Twitter record, right? So we will think like there's another file which has come. See, till now it has run once and there's a batch ID 0. Okay, now I will just copy paste the same file. This file I am copying and I am pasting in the location. Okay, and now we will go to that. See, the moment I paste it, it again started to poll and it found, okay, there is a file change, there is a data change, and let me again poll it, and it is polling and it is running its aggregation again. And now the Twitter one we had copied, right? So Twitter became 2. So likewise, while your file comes, it will get updated and the value will get incremented or whatever. Okay, so that is the way you can do. But the thing is that for very high applications, right, high scalable applications, this direct Spark streaming is not preferred. So for those, actually they prefer things like Kafka and all. So we will see that how and why we need, how Kafka helps, that also we will see. But for now, because we want to set the stage for our next Kafka thing, we want to first see how we can read a Twitter detail, so that, because our whole thing will depend on the Twitter. From now we will do whatever streaming, right? Because Twitter is a very good source, which is streaming source, but the way it streams is we will be using that port thing which I was telling, right? There can be multiple ways. One way is this file. So what happens is, this is your file source, right? When the file came like this which I copied, think that like some operation has created a file here. Whenever this file is created, it polls and it tells okay, this is the aggregation and it's supposed stored somewhere. So the same thing can be done with Twitter also. You can get the polling and you can get the details that this much Twitter Twitter trend is going, or whatever, everything you can do based on that, right? So for that, what we need to have a Twitter developer account, and we need to have 2 or 3 details. Okay, those are like the credentials, but those credentials, right, I cannot share with you because those are person to person, right, Twitters. So I will share you these code as I have done previously, but I will tell you the steps also, how to get your credential, where to get your credential, and how you can open a Twitter developer account and credentials, and how you can do. But for now I am not sharing my full code in the screen because my credentials are there in that. I have not put, because I was doing in a hurry. I could have put in another file and used that file, but rather than that I have just hard coded here and directly done it. Okay, so for this application, what we are doing, we are using a out CSV file where we are searching a string, a Twitter, and putting it. Now what we are searching is here in the tag, we are searching US elections. US elections because it's going on, right? So that's why we are searching that, so that it will update each second, right? That people are update whatever they are typing, it will get stored in our file. We want that. Our requirement is that, right? Because in your practical applications also, right, these things will come up. Either somebody will send a file, you will be reading the file, you will be putting the file, or say through some port, right, you will get that and you have to analyze and all. That also can be. And there can be other scenarios wherein you have a database change and you get it, although that can be done in queues also, like MQs, right? So that there it can be done, but this is also it depends from application to application, and based on different architectures, right, it might differ. But I want to make you aware about the detail that this way also it can be done and how it can be done. So now US elections we are searching. Okay, so the code will go, it will search what at this second people have tweeted, although I will just stop it in between because it will be huge, right? It will go on coming like that. So let's just run it and let's see what people are tweeting. Okay, see, these are what people, so this is the ID. Actually I interrupted it because many have come. Now we'll go and see in the file what's there. See, this is the file. It became so huge. So the file, what we are storing is, we are storing getting the user IDs, the time they have tweeted, is it a retweet, is it a quote, is it text, and a quoted string. So like for example, you can see this is the person's name who has tweeted, and has tweeted this thing. The US Constitution says that Congress shall set the time of these federal elections. Congress did that in something, he is typing here. Then another person has done that. So what we can do is that generally we can take this, we can analyze it, and we can find out, say we want to follow that how many people are tweeting based on some conditions, right? Because it once it comes to Spark, right, it's a data frame, and then we can analyze it, that each day how many tweets are coming and all that. This just to showcase that how you can do it technically. But of course in your project or in your real-time projects, right, these things will be used, but it might be, architecture might be a little different here and there. Okay, so this is the detail. So next what we will see is, we will go into Kafka and we will see that what better we can do in Kafka. See here what we are doing, we are reading the details and we are storing in a file, right, This is the file out.csv. This is a plain Python code. Now next, what we will do in Spark and we will do in Kafka. So as I told you, right, Kafka's main thing is that what is Kafka now. So I have put it in a separate video because Kafka itself needs an explanation of the architecture, that what's happening in it. Unless you explain it, then it will become very vague. So I will explain in another video, and I will tell what is happening and how you are reading and how we are storing and what is the advantage with the Spark. We have done it with Spark, right? We can read with a Spark, like we have shown in a previous example, this structured streaming. Then why we need a Kafka, right? So the main just I will take a little overview that the main advantage of Kafka is that Kafka is a distributed queuing. So that helps, because then what happens, you can scale based on some topics and all, which we will discuss what is a topic and how this queuing works and how it makes faster. But that makes it faster rather than in Spark. But in Spark also you can do it, you can read streams, you can even a matter of fact is that if you want, in Twitter you can directly from your machine you can write as well, you can post tweets in bulk, but we will not do that. But I am just telling that is also one way. But our motto is not that. Our motto is to read the streams and see the capabilities of these tools like Spark and Kafka. So Spark, I will do that now in the next video, and then I will be doing with the Kafka. But for Kafka, one thing is that you will need an VM. So that VM I will be giving, but the problem with the VM generally is that, you know, VMs are little slower because you need lots of memory. That's why I go for Docker and all. But this one I got a VM handy, so I went with that and I did with that, which I will be showing, right? So you guys can first emulate it, this Twitter thing. You can see how you are reading and all, and then probably we can analyze it and do in our next video that. As well as I'm planning for machine learning, but machine learning, as I told you, it will be much of a theory, so you have to know lots of theories, then only we can go deeper into it, right? Okay, so that's it for today. Thank you.